Okay, so good morning, everyone. I hope you all are doing very well and ready for the second session of our crash course in MATLAB. Um, so we will follow the same format as last time, except this time you might have also a chance to have breakout rooms. So I received some feedback from you. And one of the suggestions that I liked is to have extra exercises uploaded in the shared folder where you can access and practice on your own, and then you can come back with questions or something like that. In the meantime, let's get started. I'm gonna share a screen right now, and as always, feel free to interrupt or raise hand. Maybe if I can see the hand raised. So I'm gonna share a screen. And you probably see my MATLAB window now. And I hope all of you managed to secure an access to either installed MATLAB on your computer or an online version of it. So last time we discussed using MATLAB as a calculator, which is a very important thing from an engineering point of view. We also started doing basic plotting with the help of arrays. So arrays are extremely important to do plotting. Without them, you can't do plotting. We will start today with continuation with plotting. We want to highlight something particularly specific to plotting and dealing with arrays. And then we start getting into programming, if statements, loops, and so on. So we'll try as much as we can. We cover this time, and next section, next week, we will continue on the programming part. I want to remind you, so if you see can someone confirm seeing the screen? Anyone raise hand or say something? MATLAB is open. Perfect, thank you. Thank you, Brian. So you see the screen, that's good. So let me remind you, one way to insert an array, let's say an array X that contains the element 1, 3, 5, and 59, 9, is this, that we learned it last time. But then you might have another array that you can insert, let's say array Y. Y contains, Ibrahim, I'm assuming that just you were trying to make sure that you see the screen, or do you have a question? If you don't have a question, just lower the hand, please. So let's say we have another array, let's call it Y. It contains the elements, 4, 6, maybe 0, and 7. So these are two arrays, the array X and the array Y. One issue in MATLAB, I wouldn't call it an issue, one particular peculiarity in MATLAB is that it actually deals with everything as a matrix. And let me explain this. So if you look here on the right side, it says that this is a 1 times 4 matrix because the X, it contains 1 row and 4 columns. Similarly, for the Y, it contains 1 row and 4 columns. Then if you studied matrix algebra, something we can go over very quickly in a later session. If you have a matrix that's 1 times 4, and another matrix Y that's also 1 times 4, you cannot actually multiply them. Based on the theory of matrix multiplication, which, as I said, we can briefly cover in a subsequent section in the future. The reason for this is for matrix multiplication to happen, you really have to have the number of columns here equal the number of rows here. And since those are not equal, you cannot really perform the multiplication. And the thing is, and I'm getting to the point, why do we need this particular information about MATLAB? If you try to type X times Y, MATLAB is going to complain because it says, and these error messages are good to read just to understand what's going on, incorrect dimensions for matrix multiplication. Check that the number of columns in the first matrix matches the number of rows in the second matrix, okay? And then it's giving a hint, and that hint will be very useful. So MATLAB is confirming you cannot do this matrix multiplication. However, sometimes your goal and that you will see in plotting, very common in plotting, sometimes in one of your goals is basically just to take this number and multiply it by this number. So you want to times 1 times 4 and put it in a new matrix, a new array, let's call it Z. And then 3 times 6, which is going to be 18, and you put it into the array Z. Similarly, 59 times 0, and so on and so on. So this is called element-wise multiplication of arrays. This has nothing to do with matrix multiplication, the mathematical matrix multiplication. The theory of matrix multiplication is different. This is not how you multiply matrices. But as I said, sometimes it's quite useful that you want to have an array X and an array Y. I want to take the first element, multiply by the first, second, third, and so on and so forth. So MATLAB is saying, if you want to do this, if you want to perform this element-wise multiplication, you have to put a dot before the product, right? And to that end, I can actually clear the window here and do what MATLAB is suggesting, X dot, and then the multiplication times Y. Now it gives me an answer. Now it gives me an answer. So it multiplied 1 times 4 is 4, 3 times 6 is 18, 59 times 0 is 0, and so on and so forth. Okay. Very important. The same idea applies in division. So I can tell MATLAB, hey, I want an array, let's call it S. S is basically X, not divided by Y, because it's gonna complain, as we just discussed. I have to put a dot before the division. Now it works. You might notice something funny here. There is an infinity. Where is this infinity coming from? Is it obvious to you guys? It's from the division of 59 by 0. So MATLAB is able to recognize this. When you divide by 0, it gives you an infinity. So this is called element-wise multiplication or element-wise division. Does it apply to subtraction and addition? In fact, no. No, because the theory of matrix addition and matrix subtraction is quite the same, as element-wise addition or element-wise subtraction. In other words, if I type X minus Y, I don't need to put a dot. If I type X plus Y, I don't need to put a dot, because in this case, matrix addition and matrix subtraction is actually element-wise. So MATLAB is happy with it without a dot. So this issue appears only in multiplication, division, and exponentiation. So for example, I can say X raised to the power Y, okay, and the dot, let's see, I think, yeah. So here we go. So that's X raised to power Y, and it's basically taking every element of X and raising it to a power that equal to the element in the Y. So this is, I would call it element-wise exponentiation. Okay, guys, any question on this? This is a very peculiar point in MATLAB, and it deserves to be illustrated separately, because we will use it right now in a plotting example. All right, so I'm assuming this is clear. One more thing. We learned last lecture that MATLAB has built-in functions. So it has a sine function, a cosine, an exponential function, and so on. And we learned how to operate with these functions on scalars. So for example, I can type sine, pi, and that gives me a number that's close to 0. It should be 0, of course, be exactly 0, but there is a round-off error that happens in any computer, and that's why MATLAB is giving me a small number, almost 0. Okay, I can type sine pi over 2, and it's gonna give me 1, and so on and so forth. Now, if I have an array that contains a bunch of elements, and I type sine this array, so what MATLAB is gonna do is gonna take every element and calculate its own sign. Okay, so let's try. So let's say I have an array U. U contains, minus pi over 2. It also contains 0, pi over 2, and pi. So this is the array U. And if I calculate or generate a new array, let's call it G equals sine U. So basically what MATLAB is going to do is it's going to calculate the sign of every element. So it calculates sine minus pi, which is 0, sine minus pi over 2, which is -1, sine 0 is 0, and so on and so forth. So that's basically how MATLAB is using a mathematical function to operate on a whole array. So we learned so far how to do element-wise multiplication of arrays, element-wise division of arrays, exponentiation of arrays, and operating on them by functions. Okay. All right. So if no questions, let's take our first exercise today. Let me scan briefly, make sure there are no questions here. Don't see any hands raised. So, and as I said, if I can see your hand raised, then just interrupt by unmuting yourself. So I'm gonna take a script here, a new script. We learned that it's better to document your work in scripts, right? That's usually better. I'm gonna call this a script, you know, let's try to call it freaky plot. You can call it anything. And what are we trying to do in this particular exercise? I actually prepared a little sheet here with some suggested exercises. So we will do the first one, which is, I hope you can see it. Let me put this on the right here, and our MATLAB here on the left. Okay, so I was asked over the range from 0.1 to 5, okay, to plot the two functions, f of x equals sine 1 over x, and g of x equals exponential x times sine x. Label the axes and insert a legend at the line. Okay, that's if you have your MATLAB, it would be very, very nice if you get started working on this example without waiting us, because we kind of spend some time explaining things. And the first thing I'm gonna explain is we need to define an array for the variable x. Look, we have three variables here. We have x, the independent variable that runs from 0.1 to 5. We have f of x, and you might notice that I intentionally didn't start from 0 because I was cautious of the function 1 over x here, because I cannot divide by the 0. That's why I avoided the 0. So basically, I want to define a variable x in an array that runs from 0.1 to 5. And it could get very tedious, especially if you want a lot of points. Suppose you want your x to contain, you know, to contain 0.1, 0.2, 0.3, 0.4, and so on and so forth, all the way to 5. It's going to be very tedious if you write it between square brackets. Extremely tedious, okay? And that's why MATLAB is giving you a couple of utilities that allow you to do this without the need to manually enter every element of the array. Does any one of you guys know this? Any suggestion if someone of you know it already? Okay, so maybe no one knows. We can basically, let me write a comment here. This script plots two functions over the range from 0.1 to 5. And we learn two types of array generation in MATLAB in this particular exercise. But yes, someone correctly, Mustafa correctly said, I can do this way. And actually, oh, wait. Let's see what Mustafa is suggesting here. He's saying, so you can always test something by copying it and testing in your command window. So if I generate this, apparently it does generate. So let's see what this is doing. It's doing something weird. is doing something weird. So that's close to what we wanted to say, but it's not quite what we wanted to say. So in fact, it's very similar. I can say that the array X starts from 0.1 and it goes to 5. And if I leave it this by the column notation, MATLAB is usually taking a step of 1. That's the default. But I want my step to jump from 0.1 to 0.2. I want the step is 0.1. Similarly, jumping from here to there, I need 0.1. So if you want to put your step, is going to be between the initial and the final. So another column here and 0.1. So I can write a comment here that it will, the syntax is initial, and then colon step, and then colon final. That's basically how it works. If you want to test this, you can copy what we wrote here and put it in your command window. Let me clear the command window. Here all. And CLC. If I put this, it actually runs and it gives me 50 elements in an array. What are these elements? You see 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So what was suggested is close, but not really what we wanted to do. So this is a quick way to store the elements in the array. Let me bring this back. We also learned some useful things last time. Is usually good to clear all and CLC from the script itself that you are writing. And also, we learned to put a semicolon here to suppress or prevent MATLAB from writing this stuff on the screen. Otherwise, it takes time, unnecessarily takes time. So that's one way to define such an array. MATLAB also gives you another useful built-in function, and please learn this terminology, built-in function, something that's already implemented in MATLAB by the developers of MATLAB. It's called linspace. And the len is coming from linear space. What it does, you give it the initial point, the final point, and you tell MATLAB how many points you want in between. Like you give it, for example, here the 0.1, the 5, and tell MATLAB, hey, I want 50 points in between. When you say this, MATLAB is gonna generate 50 points equally spaced. So let's learn this. I'm gonna put it in a comment. Another way to define the array X is, let's type it here, X equals linspace. The initial point is 0.1. And then the final point is, you notice it works with a comma because it's a function. The final point is 5. And finally, the number of points that you want in between, you want 50 points. So that's another way to work it. Let's test it together. I'm going to take this guy and try to put it in the command window here. Clear all, CLT. It also works. So both of them work. Because I only need one in this script, so I would just comment this out for you as, you know, as a hint. You can learn it here, but we need just one of the two options in this particular exercise. All right, so let's continue. Remember, I just defined the array X. Now it's about time to define F and G. And we just learned how to do that just before this example. F is basically taking every element of X, inverting it, and then taking its sign. Okay, so to that end, the array F should equal sine 1 over X. Guys, is this right? Is what I wrote here right? Basically, F equals sine 1 over X, and I'm done. Or did I miss something? Based on the discussion I made here, I'm gonna take every element of X and invert it, or basically 1 divided by it. So would that work? If you test it, you will notice it doesn't work, and you actually need the dot here, because what MATLAB is doing here is generating an array of 1s and is trying to divide it by the array X. So 1 over that x, 1 over that x, 1 over that x. And because, again, it's an array element-wise division, you need the dot. And you can test it on your own and see that actually it doesn't work without the dot. Finally, I can do the same thing for d. d equals exponential x, and again, times sine x. One more time, guys, does this work? And I put some semicolon, of course, to suppress the writing. But if you test it, it doesn't work. Again, for the same reason, need a dot here to ensure this is an element-wise multiplication. Now we are ready for the plot. I want to plot the two on the same graph or the same figure. And there are many ways to do this. I'll just show you one way, but really, really many ways. So for example, I can say plot x, plot x and f. Let's make it red color, maybe dashed. Maybe I can make it with squares. You don't need to memorize this. This is stuff you usually get from the help plot command, or you search online plotting with MATLAB. So the S means the squares, so the symbols would be squares. The R means red, and dash dash means these were gonna be dashed. The other one, I can say hold on. Basically, I'm telling MATLAB, hey, stop here. I'm going to generate another plot on top of this one, and you need to put both of them in the same figure. So that's what hold on. So let me write a comment here, asking MATLAB to wait until we insert another, let's plot in the same figure. Okay, the other plot is going to be the function g. So plot x and g. Let's make it also colorful, maybe with dot with dashed lines. I can make it black. I can give it diamond symbols. I probably need a label. So x label, maybe I'm gonna call it x. And finally, y label, I'm gonna call it function. Anything. Okay. And maybe you also need a legend. Legend is basically where you tell what is each plot. So the first plot was sine 1 over x. So my legend here will contain two things: legend for the first plot and a legend for the second plot. So the first plot is, what was it? Sine 1 over x. And the second one, and you notice I not need to put this in between quotation mark because it's a text. I want it to appear as a text. And the second one is exponential x times sine x. Okay, let's run this, and hopefully it's gonna run without a mistake. I'm gonna save. Run. Does it run? So I'm not sure if you guys see my screen, but let me stop share and reshare just in case. So you see, can someone confirm that they see the plot? Something comes in the chat here. Yes, excellent. So guys, what you see here are the two functions plotted from 0.1 to 5. And the legend is nicely telling us that the red function is the sine 1 over x. The black one is exponential x sine x. But the sine 1 over x looks weird. It looks like it's a straight line. And that's not correct. It's like, it looks like horizontal. It's only deceiving because the range of the other function is gigantic. The exponential just goes down to, minus 160. And that actually shadows or makes it unclear what's happening here for the sine 1 over x. There are many ways to, to play with this. For example, you can manually zoom in. You can manually keep zooming it with this plus here. You can keep zooming in, zooming in to see what is happening in this graph. Or you can even limit the x-axis range to certain limits. Okay, so I can try to do edit figure properties. Yeah, we don't want to dwell on this for a long time, but basically you can so these are the x texts, the x labels. There should be an x limit here, although we don't see it clearly. But I'm not going to dwell on this for a long time. But you can define an x lim and limit for the x-axis, or a limit x or y lim, a limit for the y-axis, and basically you limit your plot into certain range. To avoid the fact that one function is taking very large scale, very large y-axis, and you don't see the other one. Or actually, there is another trick. I can plot it using log scale. So let me actually try this. Instead of plot, I can actually do log, which is log scale on both of them. I'm gonna save this and run it one more time. Let's see. Log scale. Oh, it's not working because we have negative values here, and that's why it's not working. Because the y-axis is actually showing negative values, and that's why you cannot take its log. So it's unclear here with the log. You cannot take the logarithm of a negative number, and that's why I'm unable to make the y-axis log. But in any case, what we see here is an artifact, because the exponential x sine x is having a big range, while sine 1 over x is limited to -1 and 1. And you can basically limit the y-axis to see the oscillations of this. I can even do something quicker here by closing this and not plotting the other one at all, just to show it to you. Maybe there is no need for this one at all, so I can comment it out. And even I can comment on the hold on. And probably if we do this, save and run again, yeah, you start seeing the oscillations of the sine 1 over x. It is nicely shown here because we removed the other function. What is the meaning of, so dash dash RD, basically dash dash means, let me bring the plot again. Let's clear all CLC from here, and let's run the script one more time. So to illustrate this question, yeah, so I hope you still see the figure here, and also the script that we wrote. So in the figure, you see that there is a dashed line that connects the squares. So, and that intentionally I inserted it myself. I made it dash dash, so I want the dashed lines to connect the data. The R means red, make the growing red. The S means make the symbols of each point, because I have point at 0.1 and 0.2 and 0.3 and 0.4. So I have a set of data points. So I asked MATLAB to make it square. Okay, I can, just to show you as an illustration, I can make this green, make this diamond, and maybe actually remove the dashed line at all. So G is green and B means diamond symbols. Let's actually see what's going to happen. First, let's close this figure, save, and run. You see now there is a diamond that connects the data, and there's no line connecting them. When I put the dash dash, that makes them connected with a dashed line. I hope this answers the question well. Any other point, guys? So if, oh, there's one more question here. Okay, perfect, thank you. I'm gonna make you into quick, let's stop the recording here. I will assign you to breakout rooms, and I will ask you to actually solve the other another exercise, which is exercise number 4 in this document. So I'm gonna stop the recording first. So it's exercise number 4 here, and I will share with you the location of this document. I'll assign you to breakout rooms, give you 5 minutes or so to work out this example, and then we come back and comment on it briefly. But for that, I need to stop the recording first. Stop share, stop recording.